Hello, everyone. Can you hear me?
Yeah.
Yeah, cool. So my name is Nikola Jankovic, and I work as a DataCube engineer and software developer at UADC. And first things first, I couldn't join with my personal or with my work laptop, so I joined with my personal computer. And I wanted to share something that's only available now on my laptop, but I will just have to show it through the slides afterwards. But some other things I was able to log in and managed to bring the servers up so I can show something as well as so next to the presentation if there's enough time, which I think there will be. So the Austrian Data Cube and the Austrian Data Cube for floods, or A-Cube for floods, are the two main projects that we have kind of brought up this service that we have. And essentially what this is, it's higher level data and analysis provided with APIs and a graphical user interface. So this user interface has been worked on through the Solomosa project as well as some other projects as well. So the idea was that the users can work with higher level data through Python, through a web interface. Currently, the way this is constituted, we have a kind of a hybrid solution, which consists of Open Data Cube. So the Open Data Cube enables data science in Python through a Python API. So on the back end, we have this Open Data Cube installed, which handles bringing the data into Open Data Cube. And this Open Data Cube is also installed on Jupyter for each user, so that they can use the same functions to kind of work with the data. Next to that, we have a threads server, which is currently just in the process of discovering and testing out different OGC web services. There was also GeoServer, which didn't serve our purposes quite fully. So for this case, we went with threads because threads is okay for accessing and working with netcdf files. Then there is Dask as well. Dask is a cluster in Python for scalable processing and analysis. So it's possible also that the users work with a lot more data. Normally, what we offered earlier was work with some data, but not at a scalable level. Now with Dask, it's possible to kind of scale up this processing and do this analysis, do mostly data analysis of regions that are larger and timestamps and more timestamps, so like a year of temporal analysis and so on. Then there is the dashboard, which is the user interface for more basic users, and Jupyter Lab and Jupyter Hub, which enables connection to A-Cube for kind of advanced users. And they use Open Data Cube and other packages as well to develop notebooks, and these notebooks can be used to mostly analyze and work with data. Karl-Heinz shown just briefly the dashboard, and I would show you this also kind of interactively, but I couldn't connect with my laptop where I have most of this set up, and the main system is not yet available. There's some configuration for user access still required, and with the outages we couldn't have it up and running. But here for the dashboard, I will just go through the elements and kind of explain the logic and ideas. So on the left-hand side, you kind of have a form which you fill out, which auto updates all of the other components. So it's possible to select their different environments. So there will be an A-Cube environment, there will be a Solomosa environment, and so on. So for all of our projects, different partners might get different access to here. Then you will select from a list of, so the list of products will be then populated, and you will see a list of products from which to choose. Then when you select the product, you will be able to select the band. Currently, it's just working with one band, but the idea is also to have kind of a selection here where you can select multiple bands. Then you would provide a date range, and after submitting, you would get kind of this flavor text, which explains gives you information about the product, and gives you a feedback and tells you, okay, this is what you selected. At that point, once you submit, so we can switch on to the right side, which is the main map. And you will see the map, the graph, the time bar, and the legend all being populated. So here you can navigate through different time slices by moving the slider. So the slider will update the image on here. And as we can see, the values are in the legend over here. And as you click on the map, you would be generating these temporal time slices or time pixel drills based on where you click. So as you click on the map or on the data, you will get this updated, and you can somehow get a very basic analysis of data. And like I said, the idea would be also in the future to kind of have bands here. So you would select multiple bands, then you would be able to query through multiple bands. In this case, this is just information up, down. And with the new data, I think there is also east-west information, which will be available, and so on. So this is kind of the UI and the dashboard, which is built for the basic user. And for the more advanced users, we would offer Jupyter Notebooks, and I will show you this later more in depth. But the idea is you have an environment where you would be able to write Python code in a modular way, test and change values, and analyze the data, and write notebooks that analyze the data. Also plots the data, and we can also do the same thing in here as we did in the interface, but we have more control over things. So the links are left here, which are relevant. So the A-Cube is located at acube.udc.ua, which is now up and online after this maintenance. If you want to read more about the products, and we try to update the wiki and include all of the products and projects in here that are relevant, as well as if you want to hear and see all of the updates on what's going on within A-Cube, you would subscribe to this mailing list. So if I would click here, you would be able to subscribe to the mailing list with your email address and your name. Now moving on, acube.udc.ua would take you to this page. And right now the dash is not available, but there will be a button to go to the dashboard here. For now, there's just the lab. So going to Jupyter Lab, and here we have some information about the service and the product. And after I log in, I would be taken to the page. And now just covering the basics here. We have files and access to our notebooks on the left, main working area on the right. I'm able to navigate through folders and to see also the products or the notebooks which are there. So we'd have some Sentinel data, some Sulamosa data, and so on. I'm not sure, so I will show just briefly the Sulamosa example that I have prepared. And if there's more time, we can have some questions and I can show other notebooks as well. This is just a very brief and basic notebook. The idea here is we have cells in which we run code. We can annotate as well in these cells. I'm just going to show a different notebook here so we can have titles. We can export these notebooks to PDF or reports. So we can have titles and flavor text, and so on, explaining what's going on. So for now, I'll just go through the code here, which I prepared. So we import DataCube, which is the Open DataCube package. We start the database connection by providing this environment Sulamosa. Then after we run all of these cells, we can list the products. And for now, there is only the single product here. We can see some metadata about this, and we can list the measurements. So this product only has the deformation up and down. Then we query for this product. We do the spatial temporal query. So this is somewhere over Austria. I'm not completely sure. If you have some coordinates, we can change this up and test this. I provide here 7 months of data, and we get 7 data sets for this sample data set, for the sample product. And due to some problems that we had with the data, I've kind of just suppressed the warnings here, but the data that's returned is this easy to work with X-array, which is a really popular tool built on NumPy and Pandas, which allows working with a structure that resembles netcdf. So here you would get access and would be able to work with this structure that really resembles a netcdf format and has attributes and everything that the original files have. Then I will do a plot. So this is the time series plotted. So we plot this through time and we can see the deformation, I guess, changing over time. And we can do a pixel drill by using this cell method, which is available with Xarray. And again, we can change these coordinates. Here I load this in a user-friendly and projection, that's the UTM-33. Of course, this can be different. This can also be WGS or something different. And here I do a drill through a point and we can see how the values have changed over time. So this is what I've prepared. I'm not sure that there's more time to talk about something, the full functionality of Acube. If you want, I can go through that. If not, we can have some questions. Thank you.